Hello, space fans. Welcome back to Space Store Live. We're here today again with Nick Howes and Terry Moseley, our space experts and astronomers on Space Store Live. And today's episode is slightly different. We brought you the 2020 special for Christmas. I hope you guys enjoy it. It's going to be a good one.
Cheers, guys. Hi, Terry. How are you doing?
Hi, Nick. I'm fine. How's you?
Good. Yeah, as Lach said, thanks again to Space Store all year, all through lockdown. This kind of regular radio show is what we call it. Kind of came about as the start of lockdown. Everyone was doing Zoom webinars, etc. And we thought we'd do something a little bit different, a bit of fun, talking about the latest news, kind of making it a bit more lighthearted, but trying to dig in a little bit more to what, say, your average news, BBC, CNN, whatever, will be doing on most of the space stories. What we've done now, because we obviously had a show only last week, we're doing one last one for the year. We'll be back in January 2021, don't worry. But last one for the year is essentially a roundup of what we think have been some of the high points of this year, some of the really big stories that Terry and I have really enjoyed talking about. Obviously, there's been so much happening this year. You know, we've had the Mars landers missions taken off from the UAE, from China, from the North Americans, obviously with the Mars rover. We've had this amazing story about the potential for signatures of life in the atmosphere of Venus. We had all of the kerfuffle over Betelgeuse at the beginning of the year, and it dimming and then coming back, and all the fantastic proof from the Hubble Space Telescope as to what happened with that. We've had the Crew Dragon mission, first time America's been able to launch from US soil since the end of the space shuttle in 2011. But this is kind of like the stories that we really have enjoyed this year. Some of them are new, some of them are a bit older. We're also going to touch on some of the people we've lost this year. Some of them are friends, some of the people we really admire in the space science community. And it's a nice mix of good stories, bad stories, and a bit of a celebration of the year, because science has done some amazing things this year. So without further ado, I'm going to kick off with our first big story of the year. And what we're going to do is kind of a little bit of a quiz for anyone who wants to post in the chat. So what collected the Bennu samples? Yep. What was it, Terry? What was it grabbed?
All right. I thought you were going to give a bit of time for people to send in an answer.
Oh, yes, they're going to post in the chat.
I think we give an extra prize to anybody that gets the full name. It was OSIRIS-REX, which stands for Origins, Spectral Interpretation, Resource Identification, Security, Regolith Explorer. And I think OSIRIS-REX is definitely a considerable improvement on that. It visited a very interesting asteroid called Bennu. Not a very big one, only about 0.5 kilometer in diameter, but very interesting because it's a carbonaceous asteroid B2 type, containing what we think is some of the most primitive material in the solar system, right back to about, if you can ever remember a very nice figure, one that's easy to remember, the age of the solar system is supposed to be 4, 5, 6, 7 million years old. 4,567 million years. You couldn't make it up, but that's what they think. So to the nearest, say, 4.5 billion years old, Bennu contains material we think that is nearly as old as that. In other words, it's primitive material indicating how the solar system originally formed. Anything that we can collect here on Earth obviously has been severely modified over the millennia and millions of years by all sorts of things, by weathering, by biological processes, by tectonic processes. The moon is quite different in that its surface has been largely churned up by asteroid impacts and so on. But we think Bennu is probably the best example that we're likely to be able to get of material that goes back to the very, very early stage of the formation of the solar system, which is obviously very important. It's also what's classed as a potentially hazardous object, a near-Earth object. They reckon there's about a 1 in 2,700 chance that it could impact the Earth within the next few centuries. That's pretty low chance, but nevertheless, it does mean that it's going to come quite close to us. So to find out what it's made of, how we might be able to possibly deal with it if it was heading directly for Earth is very important. So This spacecraft was launched in 2018, made its way out very gradually out to Bennu, which is, as I said, a tiny asteroid, only 0.5 kilometer in diameter, very little gravitational field. So it was quite an achievement to actually get the OSIRIS-REX spacecraft into orbit around it. And it had orbited it for many months, photographing the whole surface, looking for an area which would be safe for it to go down and try and get a sample. And as you see from the picture there, actually the surface is quite rough, although that's on a small scale. Excuse me, but on a larger scale, there are quite sizable boulders and depressions and ridges and so on. So they had to decide very carefully where they were going to get the spacecraft down. And of course, the scientists and the engineers were not necessarily in agreement. The scientists said, look, that's a fascinating area there. We really need to go and collect samples there. And the engineers would say, no way, far too dangerous. The spacecraft will tip over. It's not something we can do. So they reached a compromise. They reached an area which we thought was relatively flat. And they sent the spacecraft down very, very gradually. They were hoping to get what would you say, about sort of a couple of
2 kilos or so, yeah,
size worth of samples. And they did it by 2 ways, by collecting stuff from the surface and from just below the surface. And it was basically just a touch and go. It collected the stuff and went back up safely into orbit again. And they found actually that they had collected so much stuff that the little trapdoor on the sample part of the spacecraft wouldn't close properly. There were so many wee rocks in it that it wouldn't close. So they managed to get around that. They sealed it, and they now have a really good sample, and they'll be sending it back to Earth. And just sort of as a comparison, a totally different mission, but the Hayabusa spacecraft has just returned a sample from another asteroid, Ryugu. It came down to land in the Australian desert just a week or 2 ago. The Japanese mission, the Japanese scientists went and collected it. They've opened the sample, and they have a perfect collection there. Now, Bennu has about 10 times as much material as the Hayabusa sample, so we're really looking forward to it coming back, and it'll teach us something that we have simply not had an opportunity to study before, stuff from the very, very early millions of years, tens of millions of years after the formation of the solar system. Very, very important, and let's hope it gets back down to Earth safely.
Yeah, what I love about this is, as you said, it will give us more of an insight into these PH8, these potentially hazardous asteroids. And given the fact that low Earth orbit is becoming increasingly crowded and cluttered, finding these near-Earth asteroids is going to be a challenge in the future. You know, we've only catalogued possibly 95% of them so far, so there's still 5%, which is potentially in the thousands out there that we don't know about, plus the comets, etc. And you take, into account what the Philae mission and the Rosetta mission did with Comet 67P a few years ago with their touchdown successful, and surface-based sampling of that. Now, obviously, we've got several Japanese missions that have touched down on asteroids. We've got this sample back coming back from Bennu with OSIRIS-REX in the next few years. We are going to have much more of an insight into what the real composition is. And obviously, we've got meteorites, thousands of meteorites land on the Earth every year, and we can ascertain a lot of the composition of asteroids in the main asteroid belt between Mars and Jupiter. But it's really going to give us a much deeper insight, both as from a scientific point of view and also potentially from a hazard avoidance point of view. You've got the DART mission, the Didymoon mission, which is aiming to kind of deflect a small orbiting moon around an asteroid in the near future. And that, again, is going to be quite an interesting and challenging mission to see spectroscopically what comes from that, in terms of when they hit the small moon that's orbiting the asteroid itself, and getting spectral data from that, seeing what the internal composition is. With OSIRIS-REX going subsurface, again, it's having this almost pristine material that hasn't even been impacted by, the solar wind and its its kind of orbit for billions of years around our solar system. And it's also interesting, the analogy with the Apollo missions, where you've got that dichotomy and that fight between the science teams and the engineering teams, with potential landing sites and what they wanted to do, and really pushing the astronauts to a whole level of like, we've really got to go there, we've got to see this. And the uncovering with Apollo 17, which had its anniversary, its 48th anniversary this week, of orange soil with this kind of volcanic glass soil that was discovered by Cernan and Schmidt on the last part of the Apollo 17 mission. So it's all good for science, and that's the kind of running theme about what we're going through this year. Some good. Unfortunately, our next story is a bit of a bad one. But the collapse of, now it's not the collapse of Western civilization, which some people could argue, or the collapse of the Trump administration, which was a good thing for science in particular. Sorry to any of my Republican friends who may be watching or listening. This was the collapse of the Arecibo radio telescope. So Arecibo, up until quite recently, was the largest single-dish radio telescope in the world until the Chinese FAST telescope came online. This is 305 meters, FAST is at 500 meters. In the middle of a natural depression in Puerto Rico. It's been around for decades. This thing was built in the 1960s, kind of a Cold War remnant. Some of the radar capabilities have been used for surveillance and other non-astronomical purposes. It was most famous probably for its inclusion in two very successful movies. Carl Sagan's Contact, starring Jodie Foster, was a good example of that. And even in that film, and that was 20 odd years ago itself, they were talking about the lack of funding and how this telescope could be taken offline. And I think it's a national tragedy. And I think it's a real shame, and shame on the National Science Foundation, who are funding this, or not, as the case may be, as to why this has happened. This should never have happened. This should have still been operational for decades to come. There's no doubt at all. I mean, yes, you've got the square kilometre array coming online in South Africa and Australia, which is going to revolutionise radio astronomy to a degree that we can't even comprehend. The computing power to process the data coming out of the SKA doesn't even exist yet. That's how powerful this thing is going to be. It's just astonishing. The thing's generating like 10 times the global internet traffic per day from a telescope. The fiber optic cables, the cooling systems, everything that is the SKA is truly going to revolutionize astronomy if things like Starlink don't get in the way, because there's already talk about band 5B, which is one of the radio astronomy bands, being completely decimated by Starlink and having to kind of filter through this. This is the problem with radio astronomy. It's got to filter out all the junk that we're making. If you've got a mobile phone, for example, your mobile phone, you're not allowed to take one of these into places like Jodrell Bank and have it switched on. They get really upset. That kind of thing is a nightmare for radio astronomers. If you turn on a washing machine or you turn on your car engine, anywhere near these things, they can pick it up. The frequency range and capability of radio telescopes is astonishing, but then so is what they're able to do. And Arecibo, the great tragedy is it was one of the only large radio telescopes in the world that had radar observation capability. So when we had potentially hazardous objects fly by near the Earth, this amazing telescope was able to, even though you could barely steer it, the secondary that you can see there in the center of the image, which is what collapsed after the cables snapped, was its only method of steering or moving around the sky, because the main dish couldn't move, unlike, say, Green Bank and the VLA and various other telescopes, which you've got fully steerable dishes, or even the Parkes Observatory, which famously in the movie The Dish, you've got a 70-meter wide dish in most of those cases, which can be moved. This one, it was just too big to steer. Now, people go, oh, we should put dishes on the moon and that's going to get around this problem with Starlink. Yeah, we've not been to the moon since 1972. Apollo 17 was the last time human beings were on the surface of the moon. And yes, there's been some fantastic robotic missions since then. We're going to talk about some of those in a minute. But putting something 300 to 500 meters wide on the far side of the moon is a technological challenge beyond anything we're currently capable of. And yes, I'm not saying it's impossible, and hopefully one day we will see a big lunar crater with a radio telescope on the far side of the moon, you know, the dark side of the moon, to quote Pink Floyd, but the far side of the moon, pointing out into the cosmos and giving us incredible data relayed back by constellations and satellites going around the moon itself. But if we can't even look after a telescope on our own planet, and this is not the only one that's really suffering now, there's lots of historic telescopes that need looking after. And if, you know, we'll talk about the beauty and wonder of science during the rest of the radio show, but if we need to have these things operational, which we do, and we want to get the best from them, which we do, we need to look after them, which means they need to be funded. And you know, I can talk about the British government. You know, we've got friends all over the world who may be watching this. British government spending almost 1.5 times the cost of the Apollo space program on a train line. And it really annoys me when we've got these incredible scientific instruments that are delivering so much to this world that we can't even look after. So this to me is a national tragedy. All hail Arecibo is a fantastic instrument. For the 6 decades it was operational. There's talk about potentially getting another one and replacing it. For the people of Puerto Rico, this was a national icon. So it's like losing a family friend to them. I think NSF should be almost berated for this one, to not put too fine a point. This should never happen again. I don't know what you think, Terry, but that's just my kind of opinion on this.
Yeah, it's a classic example of skimping on something just to try and save a few dollars here and there. And then look what happens, the whole thing totally collapses. There is an opportunity, if the money can be found, to build a completely new state-of-the-art instrument with the very latest materials and technology and instrumentation and computing power and all the rest of it on the site, but it's going to be big money. And the trouble is now the whole of the world has been affected by the COVID crisis and having to pay for the consequences of that. So I don't think it's going to happen anytime soon. Unless one of the multi-billionaires would like to chip in some money for that, have the telescope named after them. I suppose that's a possibility. But yeah, as you say, there's nothing really quite like it. There's the even bigger new telescope, non-steerable, the FAST telescope in China, but it can't survey the same area of the sky that Arecibo did. So if there's a very interesting near-Earth object whizzing by and it doesn't happen to come far enough north for the Chinese telescope to get it, there's going to be nothing that can really radar image it the way Arecibo could. So, you know, it's out of your hands and my hands, but it certainly would be a fantastic boon for science if they were to build a new instrument in the same place.
That's the thing as well. The capability for the Northern Hemisphere, the square kilometre array, is purely a Southern Hemisphere instrument, and its ability to survey the sky down to ridiculous depths. You know, being able to pick up an airport radar at 30 light years is what the SKA is going to be capable of doing. We don't have that kind of capability now in the Northern Hemisphere. And radio astronomy is really important. Jodrell Bank, you know, all of the other North American telescopes, things like the Deep Space Network, which we obviously use for communicating with spacecraft as far out as the Voyager 1, Voyager 2 spacecraft. You know, these are really important instruments, but something of this scale and magnitude, as Terry said, it'd be great to get one of the great philanthropic kind of investors to put their name to it. You only have to look at what's recently happened with Australia with the upgrade of the telescopes, the radio telescopes there, and the fantastic new instrumentation that they've put online, you know, the complete overhaul of the Deep Space Network telescope down in Australia. And this is the kind of thing that needs to happen. We need to invest in science, because investing in science, as we will talk about later, has saved the world. It's that simple. And the potential hazard of asteroids and comets hitting our planet cannot be overstated. They say statistically it's very unlikely it's going to happen. Dinosaurs were probably thinking that 66 million years ago. Oh, statistics, who cares? One day, it's not when, it's not if, it's when. This is going to happen. And if we keep cluttering up the sky and we create a Kessler syndrome with Starlink or any of these other big mega constellations, we won't even be able to launch anything to stop it. So bear this in mind. We need to invest in science, but we need to invest in the right types of science. Now, talking about Starlink, we can move on to our next story, which is a good story. Something had a successful what? Pfizer-BioNTech had a successful trial. Yeah, that's one. But no, this is the amazing story. And I know we're quite critical of Starlink on this show, but this is the amazing story of Starship. So SpaceX's SN8, serial number 8 Starship test, if anyone saw that, if you watch the local news or the national news coverage, you'd think it was a complete unmitigated disaster, because all they talked about was the bang at the end, the big explosion. Anyone who's in the space science community or the engineering community to them, this was an absolute miracle happening. The telemetry, the data coming back from this spacecraft was remarkable. Elon Musk himself even said, yeah, 95% of this was perfect. It was amazing to watch. It was amazing to watch it launch, the 3 Raptor engines firing. They had a fault on one of the Raptor engines due to pressure in one of the tanks. I mean, these tanks were coming back almost pretty much fully fueled and trying to land vertically in a rocket that had never taken off to this extent before in this configuration, up to 12.5 kilometers. And watching it, as I was with over 1 million other people on YouTube. And that's the thing, you know, most big space missions from major space agencies don't get those for their actual mission landing attempts. This had 1 million people watching a test flight from Boca Chica. It was literally incredible watching it go up, kind of switch down the engines, go into this belly flop maneuver, coast down in a kind of shuttle type manner, then switch the engines back in, tip itself back vertical, and almost nail a landing. I mean, in terms of accuracy, it was bang on. As Musk said, it created a crater in exactly the right spot. It's phenomenal. And this thing's only going to get better and better. SN9 is imminent, you know, within the next 2 or 3 weeks, we've heard. They've got up to SN16 already lined up on the production facility at Boca Chica. I would say hopefully by next year, we're going to be seeing a full stack, fully configured Starship, like in terms of size, which is going to be the size of a Saturn V. This thing was 150 meters tall, and it managed to do what it did on its first test flight. So anyone who says this was a failure, or the BBC News or any of those, it was horrible watching the news saying, oh, look, when it blew up at the end. Yes, it blew up at the end, but nobody cared. Nobody in the engineering or space science community cared, because the thing with SpaceX is if they fail, they just crack on. They don't sit around and twiddle their thumbs for years on end and have debates and meetings and pay loads of accountants and bean counters to go, ooh, what went wrong? They just go, yeah, okay, crack on. Let's get on with the next one. Again, Terry, I don't know if you've got any thoughts on this, but I just blew my mind.
Yeah, I watched it live too, and watching the engines from inside the compartment, and whenever the first one shut down prematurely, the second one sort of just gimbaled and continued the thrust, and then another one shut down. I'm not sure if that was entirely intentional or not, but then it continued climbing on one engine. Then, as you say, the belly flop, and somebody was asking me, why does that rocket only have 2 fins on each side instead of the usual 3, like an arrow, for example? And it's obviously because of the belly flop maneuver. They bring it down so that those pairs of fins, if you want to call them that, on each side, front and back, act to brake it and stabilize it as it's falling. And then as it gets down close to the Earth, the engines cut in and reorient it and so on. And it was so nearly successful. I mean, it was only going, I don't know the actual figure, but maybe about 10 miles an hour too fast. And any more braking and it would have been a successful landing. It's a bit like getting your car into the garage, and if you let it go just a bit too far,
you bump into the wall.
You bump the bumper against the far wall of the garage and the car's okay. The trouble is, when you have a rocket full of fuel, if it goes down just a bit too fast and doesn't actually touch down successfully in terms of coming to almost complete stop, it blows up. And then you have that incredible fireball. But it was so very nearly successful. It was amazing.
Yeah, I loved it. And the thing is, you only have to look at the European Space Agency and the Ariane program. The Vegas this year have got a really bad, reliability rate. They've blown up 2 of the last 3. And that's an agency, European Space Agency are in the top 3 in the world in terms of, you've got Roscosmos, you've got JAXA, obviously you've got NASA, but ESA have got 50 plus years of heritage of launching stuff, and they're still having issues. Now, Chris Lee, it's really interesting looking at some of the chat. Chris Lee has commented, and I know Chris really well, and he said, why is SN8 important? I still don't get it. I'd say the importance of SN8 is that it's pioneering technology in terms of what they're attempting to do with these vertical landings, this belly flop approach. What they're aiming to do, obviously, with Mars, very contentious. Musk has got this big plan to send, hundreds of people to Mars and colonize it and form cities there. Whether or not he does that, who knows? The launch capability and the sheer muscle power of the SN8 in terms of its capability of what the mass and tonnage it can launch to orbit is quite amazing. We've got to go back to the Saturn V before we've seen anything in that kind of category before. Now, The upside of that is we'll be able to launch really impressive missions. You know, if you've got the fairings right and the whole stack and configuration right on the SN8, you're going to be able to launch really interesting scientific missions. However, you're also going to be able to launch hundreds or even potentially thousands of small CubeSats and nasty things like Starlink. So what most of the space science community and engineering community is hoping is that this will be used for some of the deep space missions, obviously sending, you know, potentially human beings to Mars, definitely sending like larger spacecraft to Mars. There's all sorts of, we talked about in the last show, potential configurations where you put multiple starships, one in Earth orbit, one in Mars orbit. So you've got lifeboats, you've got this kind of salvage capability if anything potentially goes disastrously wrong for a crew on the surface. I would say they're the big things that we're hoping for. What we're not hoping for is that Musk just turns this into a gigantic cargo craft for shunting up hundreds or even thousands of low Earth orbit satellites. And Starlink, don't forget, they're aiming, they've got several hundred up in orbit at the moment with a 3 to 5% failure rate. So that's not very good. Musk's eventual aim, and with the FCC, the Federal Communications Commission in North America, basically already granting licensing for, they're looking at anywhere between 30 and 42,000 Starlinks. Now, if you think right now in orbit, there are 2,787 operational satellites as of the UCS database that I checked a few days ago, and 178 million pieces of junk and debris up there dating back to the early 1960s. The last thing we want is 42,000 Starlinks, plus however many 100 OneWebs, plus whatever China put up, plus whatever Russia put up. We could be looking at 100,000 objects in orbit, in low Earth orbit. And as I said earlier on in the show, if we've got that, the potential for this catastrophic collision scale event is there. It's real. And then we won't be launching anything. And more terrifyingly, if something's coming our way, we've got no way of stopping it. We've got no deflection mechanisms at all. So SN8, yes, there's some pros and cons to this. Watching it fly, watching it do the belly flop, watching it come down. You know, SpaceX are doing things that nobody else is doing at the moment. They really are pushing the envelope in terms of, you know, engineering capability. There's been some fantastic missions from, you know, NASA with the Sky Crane and the Mars rovers, obviously what the European Space Agency are planning with Rosalind Franklin. There's some great stuff happening. But I think in terms of what the big news stories, and don't forget as well, SpaceX seem to be able to do public relations better than anybody. If you've got 1 million people watching a test flight from basically a grain silo site in Boca Chica in Texas, you're doing something right in terms of your PR and public relations. And the other space agencies, if you want to get the public on board with science and engineering and space science in particular, which we all do, and we want these kids in school to go on and become the engineers of the future, these guys are doing it right. Now, as I said, I've got a huge love-hate relationship with SpaceX. Starlink infuriates me, and it infuriates the entire astronomy community. But you watch what he's done with Falcon 9, with Falcon Heavy, and you're watching those cores, multiple cores landing vertically. Nobody else is even coming close to that right now in terms of capability. You know, some companies, as I said, European Space Agency, Ariane, the Vegas, they're not even launching at the moment properly. Rocket Labs, you know, they've had a successful launch today. They've got a good track record, but nobody's doing this yet. There's plans for some of the Scottish launch sites to do helo captures, helicopter captures. Rocket Labs have got the same plan. Nobody's matching this engineering prowess right now. And if he can do this with something the size of a Saturn V, it's going to be something to watch. Yeah. So hopefully, Chris, that answers some of the questions. Human exploration dreams, yeah, Chris has come back on that. Hopefully that answers some of the questions on that one. But it was a beautiful thing to watch. You can't argue with that. Yeah. Another beautiful thing to watch, and I'm going to hand over to Terry on this one, is an amazing achievement from those guys over that way. So someone's quest for Conservative Party quest for honesty. Oh.
Do you want to let people guess or what?
What's this one? Anyone want to go?
I've forgotten myself.
Right, so we've got our friends over in China and their quest for...
Oh, yes, of course. China's quest for the moon. My mind went blank there. Oh, dear. It's well I'm not in the quiz myself. Yeah. China is just going leaps and bounds, which is quite a good metaphor. First of all, earlier this year, they got the first automated, in fact, of any landing on the far side of the moon with the predecessor to Chang'e 5, and that was quite remarkable. We mentioned that and that's still doing science there. But the latest one now is another entirely robotic, artificial intelligence guided mission, where they landed on an area of the moon that nobody had been at before. It's near not so much a mountain as a very mountainous plateau called the Mons Rumker. Quite a big plateau, the size of a big English county, say, and it's a volcanic upland. And the interesting thing about it is that it's an area of the moon which is a lot younger than the areas that have been sampled before by other spacecraft collecting samples and bringing them back, and particularly by the Apollo missions. They were all collecting samples from areas that were 3 to 4.5 billion years old, whereas we think the area around Mons Rumker is much more recent, only about 1 billion years ago. And astronomers get used to talking about very, very big figures, very long distances, and very old timescales. So only 1 billion years ago is actually quite recent. It's about 1/5 of the age of the solar system, as we were mentioning earlier. And it's extremely interesting because, again, as I said earlier, on the Earth, we don't have anything in terms of pristine condition of that age. Everything on the surface of the Earth has been modified by either biological activity, by weathering, by plate tectonics, by ice ages, snowball Earth, all the rest of it. So this area of the moon will teach us something about the evolution of, we can sometimes refer to the Earth moon as a twin planet, because the moon is much larger in relation to the Earth in terms of mass than any other satellite and planetary system. It's only 180, over 81 of the mass of the Earth, but even so, that's quite substantial. And they have evolved pretty much together since the moon was formed. So when we can look at the moon and study it that degree of detail as we'll be hoping to get in terms of these samples, then we're looking at something that's closely related to the Earth and will teach us a lot about how this area of the solar system evolved. So the fascinating thing about it is that because of the time delay, they let the spacecraft do its own reconnaissance as it went down. It would image an area, because this was an area that nobody had visited before, image the area, look at an area, say, right, we can't land there, there's a crater there, there's big boulders there, we'll move on, we'll get somewhere else, that area looks a bit better, we'll go down a bit closer, oh dear, there's something there that isn't suitable. And they basically got the spacecraft making the intelligent decisions itself about where it would actually land. And when it identified a place that was suitable, it was down on the surface very successfully. Collected samples, taken off again, rendezvoused with the orbiting spacecraft up above, orbiting the moon, transferred the samples into that return capsule, and they're just waiting for exactly the right moment to start the return journey to bring those samples back to Earth. And they will land in about a week or so, I think, in outer Mongolia, all being well. So that'll be samples from an area of the moon that we have never sampled before, and the geologists, the lunar geologists, will be absolutely delighted to get their hands on those. But I think the really significant thing is that the way this mission was done by the artificial intelligence on board the spacecraft.
Yeah, it's amazing. And you look at the configuration of it, it's very similar to Apollo. And I'd say there's a bigger picture here, there's a bigger story. You only have to look at China's kind of history in terms of both human spaceflight, human exploration, and what they're doing with robotic missions. Their trajectory is very, very similar to the Mercury, Gemini, Apollo trajectory in terms of the first mission's quite simple, suborbital, limited crew, increasing. Now they've got plans for a larger space station. It always, to me, is kind of smacked of, we're just getting by, we're getting on with it. We're not really publicizing it as much as, say, the Americans are or SpaceX are, etc. They're just quietly getting on with it. And this whole debate, Terry and I were talking before we came on air about, the Artemis missions, and, the SLS potentially is another big story that we'll touch on in a while. But, that potentially launching for the first time with an uncrewed mission next year. But then the North American kind of NASA's get a goal to put the first female on the surface of the moon. Obviously, during the Apollo program, it was 12 men. Now, the talk about who the first woman is going to be on the moon has been a hot topic in the last few weeks. People have been saying it's this person or this person. Who knows? If China carry on at the rate that they're going, we could be on for a real space race here. They could have plans to beat the Americans to the surface of the moon. Don't forget, Artemis isn't guaranteed. You know, Biden's administration may make some changes. The whole 2024 timeline was really ambitious anyway. So realistically, you're probably looking at 2026 to 2028. Who knows? China could get there first. You don't know. None of us really know. The autonomous engines that they've used in all of the Chang'e missions, 3, 4, and 5 now, have been spectacular. You only have to look how complex this is. The Bereshit mission, the Israeli mission, crashed. There was all sorts of talk about the Indian mission having been hacked by North Korea. And, you know, if you work in the cybersecurity field, and I do a bit of work in that area for the defense sector, there's some very strong evidence that that mission was hacked just during the landing descent phase. Who knows? Who knows what China have got up their sleeve? They're a very ambitious nation. They don't have the same political churn that you have with the United States, where you've got 4 to 8 year cycles, and you only have to look at Obama and he's cancelling a Constellation mission, and then Trump saying we're going back to the moon and really forcing this through. And what Jim Bridenstine's done at NASA has been remarkable, truly, truly amazing. Greatest thing that Trump did by a country mile. But potentially he's not going to be there for much longer. It could be Alan Stoffman, it could be any number of people taking over at NASA, whether or not their ambitions are the same as Bridenstine's in terms of getting back to the moon. It is seen now really as a national goal, and I think it would be kind of a bit mortally embarrassing for the Americans to pull back at this stage and not go for the moon with human exploration. And we do need to go back. You know, Professor Ian Crawford at Birkbeck College in London is a massive advocate for this. And you only have to look at, we talked about the sample return missions. With Apollo, you're looking at just under 400 kilograms of samples that were brought back that we're still researching to this day. And, you know, some of these sample return missions, it's a few hundred grams to a few kilograms at best. And yes, it will get better, but this is an interesting one. So all I'm going to say is if you get a chance, have a look at what China are doing. Also, with all of these stories, dig into our previous shows. They're all available on YouTube. We go into a lot more detail in some of the previous shows. This is more of a roundup. But with China, it is watch this space. Absolutely. Moving on then, as the Oscars and various other, like the Emmys and the Grammys and various other shows do, they always have a section which is kind of like who we've lost this year. And we'd like to do the same because there are some really, really special people that have passed this mortal call this year. And it's not COVID that's caused, you know, hopefully and thankfully in many of these cases, their demise. They've really reached incredible milestones of their own account. The first of these is the wonderful Katherine Johnson. This lady wasn't really known, or very, very little known about her outside of the kind of NASA and space science community, until Margaret Lee Shetterly wrote a book called Hidden Figures, which was then adapted into an absolutely marvelous film. In terms of accuracy, the film's not great. Knowing many of the flight controllers, I know people like Glyn Lunny, Joe Griffin, etc., people who were there, they'll tell you all sorts of stories. Dutch von Ehrenfried, another great guy from the kind of Mercury control room days. You know, you talk to him about, you know, the story in Hidden Figures, and he says, oh, it's a lot of baloney. But there is a lot of truth in it. Katherine Johnson did do some remarkable work. She did do a lot of the trajectory calculations, literally by hand, with very basic computing capability at best, all through the Apollo, you know, from Mercury through to Gemini through to the Apollo era. Her numbers were asked to be cross-referenced by John Glenn. That, you know, that is a true story. She wasn't in mission control. There's all sorts of things associated with that. And obviously, historic racism was a real problem, you know, not only for her, but for Mary and for Dorothy Vaughan, the other two figures who were depicted in that really terrific film. Dorothy Vaughan, I mean, she was an icon in computing. If you're in any way interested in the history of computing and computer science, Dorothy Vaughan is one of those major figures. But Katherine Johnson, she was 101 years old. She'd received the Presidential Medal of Freedom from Obama, long overdue. A lot of the people who were involved in the Apollo space program in particular should have been given a lot more credence and credibility and awards really for what they did. But a really amazing lady. I don't know if you got any thoughts on her, Terry, but just incredible.
Yeah, I really enjoyed the film, particularly the bit for IBM where wheeling in this huge room-sized computer, and it was basically only able to do more or less what she was able to do in her head. But the difficulties they faced, it wasn't just a discrimination in NASA. to even get to the stage where they became brilliant mathematicians with the schooling that they had available was an incredible feat. Segregated schooling, obviously, and an awful lot of people then, I suppose it maybe even happened in white schools at that stage, thought that women were not meant to be scientists or mathematicians. You know, they were meant to be trained in domestic duties and so on, and go and be good housewives and so on. So she faced double discrimination, both sexual discrimination and colour discrimination. So for her to reach the heights that she did was, as you say, absolutely remarkable. It took a long, long time for their achievements to be recognised publicly, as you say, within NASA. It was probably pretty well known. But it's really great to see that they're achieving the recognition that they deserve belatedly. But yeah, fantastic.
Yeah, a life that deserves to be celebrated and remembered. Absolutely. Moving on to our next sad loss this year, Freeman Dyson. Now, I first came across this guy from reading a lot of the works of Richard Feynman, who was an icon in terms of science, Nobel Prize winner itself, obviously himself for quantum electrodynamics, and a lot of the work that he pioneered with nanotechnology. Freeman Dyson is referenced quite a lot in Feynman's many books. And I first came across Dyson through that, and also through, remarkably, a project called Orion. Now, this isn't the Lockheed Martin kind of capsule that's going to take us back to the moon, the glorified Apollo command module capsule, a slightly larger version of that that's Lockheed Martin have been building. It's going to be mated with the European Space Agency's service module. Now, Orion was this nuclear-powered spacecraft. Now, don't forget, this was in the height of the Cold War, where detonating anything nuclear was seen as bad. You know, the Americans were blowing up Bikini Atoll and various other places, and the Russians were launching dropping or testing the Tsar bomb, which is probably one of the largest things ever to blow up that's made by humans, apart from the N1 rocket. The largest non-nuclear explosion was a Russian rocket, the N1, which was their Saturn V equivalent. But this thing was incredible that Dyson was proposing, where essentially you had this gigantic plate on the back of a huge rocket, and you drop atomic bombs through this plate, which would then explode and propel it forward at greater and greater velocities. And the potential eventual velocities was staggering. But obviously they had the major problem of, how do you launch something into low Earth orbit that you're dropping loads of nuclear bombs behind? And the idea has been taken on and used in many, many science fiction films, the whole idea of nuclear propulsion. And we probably will have a form of nuclear propulsion at some stage. But I mean, Dyson, Terry, you were saying just before we went on air, this guy was a real polymath. It wasn't just that, he did so much.
Very much so, yeah. I must say, look at that photograph. This is very irreverent, but I'll go on to say much more favorable things about him. It reminds me just very much of the cover of the Roald Dahl book, the BFG, the Big Friendly Giant. So with that little thing out of the way, yeah, I have to admit he's totally out of my comfort zone in terms of the maths and the science. He was a mathematician, statistician. He worked in astrophysics and quantum physics and nuclear physics and engineering, all at levels that would leave me way, way behind. And I hope I'm not offending anybody who may be watching by saying probably over most of your heads too. So I'm just going to mention one thing that he's probably best known in the sort of popular community for, the so-called Dyson sphere. Now, we are pretty energy intensive on this planet, far too energy intensive. But if you fast forward into a few tens of thousands of years into the future, where we become hopefully a very, very advanced technological civilization, we may be at the stage where we need even more energy. And the Dyson sphere was conceived by him as a way of harnessing almost all of the energy produced by a star, basically by enclosing it in a sphere. Now, not a totally solid sphere, I don't think that would work at all, but a sphere which would trap a fair amount of the radiation being produced by the star, and that would be available for whatever purposes you want. Now, technologically, that is theoretically possible. In terms of our capability at the moment, it is totally beyond what we can even dream of, but who knows what's going to happen in the future. So the Dyson sphere went into sort of popular science and science fiction mythology as what you could do. Another interesting idea that he came up with was that if other much more advanced civilizations than us had already built things like this in the galaxy, it would be possible to detect them by the peculiar variation of infrared radiation that they would give off. In other words, they would observe all the radiation from the star and use it. But what would be given off and emitted outside that sphere would be infrared. Now, there are other objects, even stars, that emit quite a bit of infrared radiation, but it would be possible, analyzing the spectrum, to detect whether this was a Dyson sphere or not. So a lot of people took up this idea and thought, well, an actual sphere that captures maybe 90% of the energy from a star, which is absolutely colossal. I think I made a note of the sun's radiation, 3.9 by 10 to the power of 26 joules per second. Absolutely mind-blowing. I cannot imagine any civilization that would actually want that amount of energy, although perhaps if it was a civilization around a red dwarf star, that might be more feasible. But anyway, there were other variations on that, the Dyson swarm, which would be a whole fleet of satellites basically using solar energy around the star, not one single structure, and another variation on that, the Dyson bubble. So a lot of people ran with the idea, they modified it, they came up with other ideas. I don't know if anybody has ever made an actual attempt to detect a Dyson sphere or a Dyson bubble, but who knows, sometime in the future somebody may start a program to actually look out for that. But yeah, fantastic man, as you said, a polymath, brilliant in so many different spheres of maths and physics, and he made a tremendous contribution, and he'll be greatly missed.
I think the likelihood of a Dyson sphere, given what we're about to do to low Earth orbit, who knows? I mean, we spent the last century trying to blow each other apart with mutually assured destruction. So, good luck if any advanced civilizations out there. You may be listening to our radio show or our podcast, but yeah, good luck on that one. Our final one. I mean, there's been so many people we could talk about. This one's very personal to me. I knew Al very well. We went on tour together around Europe. We were in Switzerland. We did the first ever Apollo astronaut visit, official visit to Wales, when we went down to Treorchy and packed out a theatre like completely twice with school kids in the afternoon who were absolutely inspired beyond belief. And then later in the evening with a fully paying audience. Al used to come over. He was an honorary Anglophile, or an honorary Brit, as it were. He loved being over here. The Empire Test Pilot School, which is just down the road from me here in Wiltshire, is where Al learned a lot of his skills. Flying, he was sent there by none other than another person we're going to talk about, Colonel Chuck Yeager. Absolutely incredible, this guy. Obviously, he's wearing an astronaut suit because he was on Apollo 15. He was the lunar module, command module pilot on Apollo 15. So whilst Jim Irwin and Dave Scott were on the lunar surface, Al was doing observations. Farouk Al-Baz, famous geologist working at NASA, had given him incredible amounts of training. Al was a fully qualified and trained geologist. And from orbit, he was detecting things and imaging stuff that nobody had ever seen before. You know, cinder cones, evidence of volcanic activity. He's in the Guinness Book of Records for 2 records, being the most isolated human being in history and the deepest spacewalk in history. The EVA coming back on Apollo 15, you know, you talk about spacewalks now when they're on the ISS and they're a few hundred kilometers up, or on the Hubble where, you know, 400 to 500 kilometers up. Al was over 200,000 miles away from the Earth when he did his EVA coming back on Apollo 15. I mean, if you want nerve-wracking, he's one of only 3 people in human history to do that, being the last one being Ron Evans on Apollo 17, Ken Mattingly on Apollo 16, where they had to retrieve the film canisters from the service module that were taking, you know, some of the images while they were in orbit. Absolutely incredible. And I loved the stories. The guy loved Grey Goose and cranberry. That was his drink of choice, Grey Goose vodka and cranberry. And he just talked for hours. And literally, when we were in Switzerland, there was a queue of nearly 300 kids at this school waiting to look at the moon through the Swiss school. This was Aiglon College in Switzerland, through their telescope at the moon. And I would just be saying, look, that's a landing site, that's Hadleyville, because it was the right phase to see that. And he was pointing out all the features on the moon. And these kids were absolutely enthralled. And then we gave a talk together on stage the following day, a thing called the Round Square Conference, and there were people like Sir Jackie Stewart was there, and the Aga Khan was there. You know, it was a really distinguished group of people that were invited to speak, and Al was the keynote speaker. He was the high point of the whole thing. anyone who ever met him or ever knew him knew what he was like. He was just, he almost seemed indestructible. And to think that he passed so quickly earlier this year is a real tragedy, because, you know, I talk to him quite often, like I said, on tour with him, and he really looked like he could fly again. He looked like he could genuinely just hop back into the command module and fly again. Always a good laugh, a great guy, great stories, absolutely sorely missed. And we've lost quite a few of the Apollo guys now in the last few years, not only the astronauts, but the flight controllers, Ed Fendell and various other people that we've lost. And we've got to keep these stories alive, because until we go back to the moon with Artemis, this is all we've got. You know, 12 human beings and 24 people in total have been into lunar orbit, and 12 have been on the surface, and the 24 have been into lunar orbit. You know, some of them did several missions to the moon. Obviously, people like Jim Lovell on Apollo 8 and Apollo 13. Gene Cernan on Apollo 10, Apollo 17, John Young on Apollo 10, Apollo 16. You know, there are people who've been there more than once, extremely fortunate. But these people, you know, apart from Jim Lovell, you know, now are no longer with us. So these are the kind of people that need to be revered and really need to be held close to our hearts. And it's kind of, it's my mission in life, I've always seen it, is to really communicate that what Apollo did for humanity, because it's so much more than just planting a flag on the moon and winning a geopolitical race with the Soviet Union at the time. But really sadly missed. I love this guy so much. So
yeah, I had the honor of meeting him once at the Kennedy Space Center. A really human guy, very modest, but a real delight, and something I found out just slightly too late. He shares the same birthday as my partner, so if we'd known that at the time, we might have got an extra autograph from him or something. But yeah, a really, really lovely guy, and again, just one of those ones that's so sad to see them go.
Yeah, it really was. And I said this was our final one. It wasn't actually, because we do have one more that was quite recent, and that was Colonel Chuck Yeager. We talked about him during our last show. Amazing guy. You can see him there in the filming of The Right Stuff with Sam Shepard, which was quite an interesting one, because Yeager played the barman in the movie of The Right Stuff. And he always said that he spent more time in the bar than he did in the air. Famously on the Bell X-1, if you've been to the Smithsonian Museum, the Bell X-1 is there. It's one of those goosebump moments in terms of seeing the aircraft that first in level flight beat the sound barrier, because there's all sorts of talk during World War II of like some of the diving aircraft were capable of beating the sound barrier. But in level flight, the X-1 was the first one to officially do it in 1947. Again, a huge life. What an incredible life that he'd led. And it's one of those things that I think is indicative of, he could have been every bit the astronaut that Al Worden or Neil Armstrong or anything were. He was a phenomenal test pilot, most famous on the X-1 breaking his arm and getting one of his ground crew to help him with a sawn-off broom handle to pull the hatch over on the X-1 because he couldn't close it when it was being dropped. Again, pioneering, because the X-1 then went on to the various other X-planes and eventually the X-15, which was, you know, still the fastest aircraft ever to fly in level flight, and still so much of the data from that fed into the programs like the Space Shuttle. So his contribution to human space flight and space in particular is immeasurable. And again, a really sad loss this year. I don't know if you've any thoughts, Terry.
Yeah, very much. The Right Stuff really was what they had. And in those days, it was literally flying by the seat of your pants. It wasn't computer-controlled flying. You were in charge, and if things went wrong, it was up to you to use the controls manually to come out of the spin or come out of the stall or whatever it was. So the highest of admiration for people like that.
Yeah, he was one in a million.
Right Stuff really was what
I've just got you on my radio there, Tate, on my YouTube channel. Right, so what a year for science. I mean, you can put your own word in there. Phenomenal, incredible, staggering, beautiful, wonderful. It really was. We talk about space science a lot, obviously, on this podcast, but this year has proven the value of science to all of humanity. And again, you know, anyone who's listening, I know Chris Lee is in the audience and he's a big advocate of this, but anyone who's listening out there, it is our responsibility to communicate science to the general public as much as possible. And when you've got politicians who may not be making the greatest of decisions all the time, and you've got politicians who shouldn't even be in office, who are completely incompetent, and that goes on both sides of the Atlantic. I'm not just tapping into, the recently deposed incumbent of the United States. It really is our responsibility as people who are passionate and love science to get this message out. And you only have to look at the BioNTech Pfizer vaccine and the work done by AstraZeneca and the Oxford University team and all of the other academic and university institutes and industry bodies around the world that have collaborated to do something that's never been done before. I mean, this is on a scale not quite of Apollo, but this is a huge scale thing. The Earth has been hit with something the like of which we haven't really seen in modern history before, and to be able to develop a vaccine for this in like 1/5 of the time that any other vaccine had ever been developed, and the Ebola vaccine, I believe, at 5 years was the second fastest. It again shows the remarkable nature of science. The mRNA work that was undertaken by BioNTech. And you think about, we were talking about Katherine Johnson before, and Mary Jackson and Dorothy Vaughan during Hidden Figures, and the horrendous kind of racism and persecution that these people faced. And the two leads at BioNTech, these are descendants of Turkish immigrants in Germany. And with the UK about to kind of decide to leave the European Union, it couldn't be at a worse time. In terms of both science and the economy, etc. But it shows that collaboration across borders is so important. Two Turkish immigrant family members living in Germany are about to save the world, or be part of a team that's going to save the world from this thing. Because we don't know, the next COVID could be far worse, but the research that's gone on and the science and the background behind this that has been undertaken and the collaboration by all of these major companies and scientific institutes has been so phenomenal that we now have a fighting chance, even if this thing mutates, or if a new COVID comes along or something else springs out of the woodwork. We've now got a scientific backbone that's demonstrated that we can tackle even the biggest challenges. So I don't know if you've got any other thoughts on this, Terry, but I just think it's such an incredible achievement.
Yeah, that was absolutely remarkable. What struck me there, just as you were talking, is that you and I are mainly interested in things that are absolutely huge, vast, very distant, tremendous energies and so on. But what really made this possible was the way sciences are coming together now at the subatomic level, basically right down to the quantum level. Quantum physics now is dictating an awful lot of what we're learning about the very, very fine structure in biology and chemistry, as well as obviously in physics, and the way that we can manipulate individual genes, look at things at the molecular, even atomic level now, and work out just how this virus works and what needs to be done to counteract it and so on, showing the way there's a synergy between all the different branches of science now. I'm certainly no chemist, a little bit of biology from school and university. My physics is very limited, but the way I understand it is that things are now basically coming together where all the sciences interact now at that very, very basic level. Even in human biology, understanding how the brain works down at the level of individual neurons and synapses and so on. And science really cannot be underestimated. I cannot believe how politicians of whatever hue can say that science doesn't matter. Science is basically what is driving the world at the moment. And they're such hypocrites. They're using modern technology to communicate on their smartphone or whatever, and the aircraft that they fly around in are basically flown by computers. And yet they denigrate this. They say, we don't need science and so on. It's unbelievably short-sighted, and basically it's willful short-sightedness. So yeah, absolutely fabulous in terms of what happened with COVID. I couldn't agree with you more. But as I said, you and I are more interested in things that are on a much larger scale. And just one of the things that I'm going to talk about a few things. Again, it sort of comes into the overlap between all the sciences. The Gaia mission which is a mission to understand our galaxy in an incredible amount of detail. It has already released 2 huge databases in terms of measuring the sizes and distances and motions of objects within our galaxy, and it's just released a 3rd one with another, I think, 30 million stars measured to an incredible degree of accuracy. And you might say, well, why is that so important? Well, basically, knowing the distance to a star is one of the most important things that we have in astronomy, because unless you know how far away an object is when you're looking at it in your telescope, you don't know how big it is. Is it a relatively small star close by, or is it a really big star very, very far away, to put it at its simplest level? Same applies to galaxies. And whenever we know the mass of a star and the temperature and so on, we can work out basically how it's working. When we're looking at planetary systems around other stars, we also need to know how far away they are. So the Gaia mission is an absolutely huge amount of data that has just been released for the public. Far too much technical detail to go into here, but that will revolutionize our knowledge of what's happening in our area of the galaxy and astrophysics in general.
Yeah, I think that's one we've got to. I think we should cover that in January, because it is, as you were saying, a quite amazing mission. The other thing is, whilst we talk about the large scale, obviously things like quantum mechanics and nuclear physics, etc., all comes into astronomy. You only have to look at some of the COVID vaccine development, which has been going on at the Harwell Space Cluster. So Harwell is a UK kind of campus, as it were, which has hundreds of space companies, ranging from small and medium-sized enterprises through to some of the quite large players in the field of space science and space engineering. And they've got a big thing there called the Diamond Light Synchrotron, which is this basically particle accelerator. That's been instrumental in some of the work on COVID. So this crossover between the different scientific disciplines is so important. And I think hopefully now, once we've got the vaccine rollout and we've got back to some semblance of normality, the public won't forget what science has given to them, what science has delivered to them. And you only have to look at, climate and the whole debate over climate change and climate science, which was for years, even the BBC would have to say, well, these people believe that it is happening and these people believe. They don't do that anymore. It's happening. Everybody now accepts that it's happening, unless you're orange and were formerly the president of the United States. Everybody accepts that climate change is happening. You have to look at that gigantic iceberg that's currently drifting towards South Georgia in the South Atlantic to see, this is horrific stuff that's happening right now. The forest fires in the northwest of America. These things are getting worse and worse. Flooding, it's getting worse and worse, and it's science that's going to save us in these respects as well. We need Earth observation. We need these satellites, but we don't want to overcrowd it. It's like anything we do. If we are going to start chucking plastic into the ocean, one day it's going to come back and bite us in the proverbial, and it is doing. We don't need this. We need to be respectful of what we do. Science is there to be cherished, to be nurtured, and to be loved. And yeah, it's been a wonderful year for science, and long may this continue into 2021, which is what we're going to touch on now as our kind of little final article. So what to look out for in 2021? There's so much. Terry's got a list as long as your arm. I've got a list as long as your arm as well. We're running quite over on this one, but we'll just very quickly. James Webb, the JWST, which is a successor to the Hubble. It's not a replacement for the Hubble. It's an infrared telescope. This thing's going to be a challenge, shall we say. We've got a 25 square meter mirror or mirror configuration it's astonishing. I mean, this thing's vastly bigger than the Hubble. The way it's going to be launched is on the European Space Agency Ariane 5, so we're all finger crossing on that one, given what's happened with the Vegas at the moment. If that thing blows up, it's going to make the Boston Tea Party look like a walk in the park. It's going to be horrific, because this telescope is already decades over in terms of its original launch schedule. It's so far behind. Some of the instruments for it have been ready for years. It's so big you can't test it fully. You can't integration test it because the sun shield for it is the size of a tennis court. The mirrors have to unfurl. If you go on YouTube and have a look at some of the videos of the James Webb kind of unfurling, and it's going out to L2, Lagrange point 2. So this thing's going to be 1.5 million kilometers away from the Earth. Therefore, there isn't a rescue. It's not like the Hubble. If something went wrong, they could send up astronauts. People like Mike Massimino and John Gunsfeld all went up and did a fabulous job of fitting co-star and all sorts of things onto the Hubble and fixing it and getting the optics right. This is a one shot. If it goes wrong, that's it. And the cryo cooling, it's only got a limited lifespan because it's an infrared telescope. It's got to be cooled down to ridiculously low temperatures. The sun shield's got to work and not tear. Like I said, you can't integration test this thing because there isn't a vacuum chamber on the planet big enough to integration test it. I was very fortunate to be invited over to Goddard Space Flight Center into the clean room to see this thing being built. It is amazing. It's absolutely huge. The gold on the mirrors, even though these mirrors are enormous, they're like the size of a school hall in terms of the mirror configuration size, the amount of gold on it would fit onto a golf ball. It's in the angstroms thickness. It's an amazing, amazing mission. So that's kind of one of my picks for next year. Obviously, we've got Artemis coming with the SLS mission. Virgin Galactic may eventually get something working, not misfiring. Terry, what have you got? You've got loads as well.
Well, there's the 3 missions already on their way to Mars. I think Perseverance is probably the one that will be following with the greatest amount of interest because it's so ambitious. It's due to land on February the 18th. Be another few minutes of terror as it goes down. But they've managed it reasonably successful so far with other similar missions. So we're hoping that's going to be okay. Just in terms of the sky, one thing I must mention before we leave this year, and that is the extremely close conjunction between Jupiter and Saturn in the evening sky on the day of the solstice, December 21st. Do have a look at that. If you Google it, you'll get more information than I have time to give you here. And the other thing of note coming up in the sky next year is a partial solar eclipse. First one we've been able to see in UK for quite a while on June the 10th. Not terribly big. The visibility ranges from about 32% of the sun eclipsed in London up to about 50% in northwest Scotland. And that's June the 10th. Hopefully good weather, and it's the sort of thing you can see without a telescope. In fact, if you have a telescope, you don't look directly at the sun. Again, there'll be a lot more information on the safety of that, but that's something that everybody could enjoy. So between that and what's happening in space, it's again going to be another incredible year.
Yeah, keep an eye out for that Jupiter-Saturn thing. They're already getting close. I was out tonight looking at them, and the angular separation is going to be down to about 5 arc seconds. If you don't know what that means, basically, if you've got a good set of binoculars, you're going to see both planets in the same set of binoculars. Even if you've got a nice wide field telescope, something with a low focal ratio, you're going to see both planets. I'm expecting a deluge of images for competitions like Astronomy Photographer of the Year next year coming to that. Everyone's going to be taking pictures of it. Definitely things to look out for. Like I said, hopefully early January, we're going to be well on the way to COVID vaccine rollout. It's already started in the UK, started today or in the last few days in North America. Hopefully, by the time we get round to that wonderful partial eclipse in June, we're all going to be actually able to see each other. And again, I just want to say a massive thank you to everyone at the Space Store. They've been terrific all year, really supportive of us. These shows were initially going to last for half an hour. Tonight we've way overrun, so huge thanks to Luke and Latch, always behind the scenes, always so supportive, putting this stuff together for us, helping us with the streaming, etc. Once we're out of lockdown and out of whatever tier you're in at the moment, if you're anywhere near the Didcot area, near the Harwell Space Campus in Oxfordshire, pop into the Space Store. They do some funky stuff with VR. They've got some great things as well. If you're still looking for a last minute Christmas present, they've got some cool stuff as well, so have a look at their shop. But huge thank you. And when we first talked about this at the beginning of lockdown and these kind of short shows, I put out a thing to basically try. I wanted to get Terry involved. I've known Terry on and off for years now. We've met each other in person a few times, and I've been over, really kindly invited over to Ireland to give a few talks myself. He's an absolute ambassador for space and astronomy. I can't speak highly enough of him, and he's been an absolute joy to be with on this show, and hopefully progressing into next year. We've just got to stay safe over Christmas and make sure that we do what we're told to do and not interact with too many people over Christmas. But there you go.
Nick always beats me to it. I would say exactly the same thing about him. His knowledge is voluminous, and like me, he really, really enjoys putting it out to everybody, and that's the best we can do. We really enjoy the subject. We want other people to do it as well. So goodbye to everybody. Happy holidays, as it says there. Have a cool Yule or satisfying Saturnalia, or happy Christmas or whatever, and hope to see you all again in the new year.
Yeah, however you celebrate, just enjoy it, and get some good quality time with the people who mean a lot to you if you can, and if you can't, hopefully this will be a one-off and we'll never have to go through this again. But yeah, anyway, handing back to our amazing friends at Space Store.
Yeah. Bye.
Thank you, Nick and Terry, once again for an incredible roundup. I just want to add a big thank you to both of you for bringing the roundup, making the roundup a thing, and you've been so supportive ever since lockdown began. We've been doing this every fortnight, and I've learned so much from you guys. I'm sure everyone who's tuned in has learned a lot about space and been inspired to look up. So big thank you to Nick and Terry. I hope you guys enjoyed the show tonight. I hope everyone stays safe over the holiday period. And a big thank you to everyone who's tuned in since April when we started this. We couldn't have done this without our fans, our space fans. And thank you for your support and thank you for your interest in Space Store Live. We are slowly growing. We're getting bigger and bigger. And it's thanks to you guys in helping us bring space to everyone. Nick and Terry, I hope you guys have an amazing Christmas, and we'll see you back here for Space Store Live kicking off in the new year on the 12th of January at 7:30. Happy holidays, guys. Take care, and we'll see you next year.
Take it easy. And if you enjoyed the show, like us on YouTube, tell your friends. You know, it's all good. We're just trying to do as best we can for STEM and outreach. So huge thank you.
Thanks to everybody there. Bye-bye.
Good night from me.
Good night.